P and Q are prime numbers. Really? Capital P is equal to small p to the power whole cube into Q. And capital Q is equal to small p, small q, whole to the power cube. Okay. Where small p and small q are prime numbers. Okay. And find the LCM of this one. Same as HCF. Now wait. P and Q are prime numbers. Really? Express the exponent of 5 in the prime factorization of 3750. Hello everyone. So I welcome you all to this new lecture on real number. Till now we have seen Euclid division lemma, algorithm, then fundamental theorem of arithmetic. Okay. We have already seen two lectures on fundamental theorem of arithmetic. No, two cases. Now this is another case on fundamental theorem of arithmetic. Now, before starting this one, I want to say something. Let's say any number is given. Then there are two possibilities. Either that number could be a prime number or a composite number. Okay. If it is a prime number, then it will have two factors. That is 1 and itself. If it is a composite number, then it will have 1 itself as well as few other prime factors. Okay. Or any factors. Generally it is a prime factor, few other prime factors. Okay. So let's say any number is given. Either it will be prime number, composite number. Then draw the factor tree. Okay. That you have done in smaller classes. Draw the factor tree. Then write each factor in a product sign. Okay. Then compress the similar factors in the power. Let's say 2 into 2 into 2 into 2 something is given. Then 3 into 3 into 3 into 3 into given. Then what I've said 3 times I have said that 2 3 times and 3 4 times, that means 2 to the power 3 into 3 to the power 4. Okay. Similarly, there is another problem. This also there in the previous year sample paper questions. So let's try this one. So what they have said, express the exponent of 5 in the prime factorization of 3750. So 3750 is a number, either it is a prime number or composite number, but this is a composite number. Okay. So we'll draw a factor tree. Okay. After drawing the factor tree, we will write its factor in a multiplication form. Then we will find the exponent of 5 in the prime factorization of 3750. Okay. So let's draw the factor tree. Wait a moment. So 3750. So let's do the 3750. If you give 2 times 10, 2 1 and 2, remember this one, that one, and 17, 2 8s are 16, 2 8s are 16, that's what carry 1, 5. Then 2 7s are 14, carry 1, 10, 2 5s are 10, okay. Now with this one with 5. This will not go with 3, so let's try with 5. Then 5 3 are 15, 3, and 37, and 5 7 are 35, 2, and 5 5. Then again this one with 5. 5 7s are 35, then 2 remainder, then again 5. Again this one with 5, it will go 15 times. Again with 5, it will go 3 times. Okay, this is the factor tree. Now, simply we can write 3750 is equal to 2 into 5 into 5 into 5 into 1 2 3 4. There are 4 5 into 3. Okay. 2 5 3. Okay. Now what they did, the exponent of 5, that means they are asking this one, 2 into, to the number of times the 2 is there, 1 times, number of times the 3 is present, 1 times, number of times the 5 is present, 1 2 3 4, the 5 to the power 4. Okay. So the exponent of 5 in the prime factorization of 3750 is 4. Okay. Then option B is correct. Okay. This is the previous year, this is a type of previous year question. There is another similar type of question. Let me do this one. So let me write a question first. If capital P and capital Q are two positive integers, so here this one is the question. If capital P and capital Q. Capital P and capital Q are given, so are two positive integers such that capital P is equal to small p to the power whole cube into Q, and capital Q is equal to small p small q whole to the power cube. Okay, where small p and small q are prime numbers. Okay, and find the LCM of this one. Same as HCF. Now wait, P and Q are prime numbers. Really? Then that's a very good news, because what you do in the factorization table or the prime factor tree, that on the tree one. So we are doing the prime factorization using the prime numbers, but they have already said that P and Q are prime numbers, and they have said capital P as this one, capital Q as this one. That means capital P is equal to small p into small p into small p into Q as per given. Capital Q is equal to small p into small p into small q into small q. How? As per this given condition, capital P is equal to small p, and we'll get small p, and small p, and we'll get small p 3 times. Small p, not small p, we'll get something. We'll again get something. We'll again get something. Then it will be very small p. How many times? 3 times. So 1, 2, 3 times. Then small q. Okay. Either this could be in this format, or this could be of this format. Okay. This capital P. Similarly, the capital Q. That means, since P and Q, small p and small q are prime numbers, that means these are the expansion. This P and this capital P and capital Q are having this expansion. So how we are going to do the LCM and HCF? Simply, for LCM, first let's see that common one. Small p, that means 2 times small p into small p. Now small q how many times? 1 times. So into small q. Now how many times p left? 1 times. How many q left? 1 times. So 1, 2, 3. P to the power cube into how many times small q? P to the power square. Okay. So this is the LCM. Now if they ask about the HCF of this one, very simply, 1 times common, 1. 1 times similar, 1. Q times 1 times 1. So this one. So if they ask about the HCF, then it will be of P square into Q. Okay. This is one of the various sample paper question that is coming regularly. Okay. And in 2024, I think this similar type of problem has came. So let's try. And there are various other problems that I am having. So I am going to do this one in very soon. So keep learning. Bye bye.